Thanks all for turning up. I'm going to talk more or less about AWS and a little bit about microservices. Microservices, I'm winging it a little bit, which I'm going to be teaching you. A lot of you guys will know more about microservices than I will. It's very applicable to AWS though, which is why I want to kind of strap it onto the end. As interactive as possible. If you want to shout questions out at me, stop me mid-flow, please do. It's not a massive slide deck. I wanted to kind of go through the interface of AWS more to kind of explain it as we go through. Just a couple of things as a reference. So I'm logging into my personal account. Just didn't want to get into any of the proper accounts we've got. I have one of these. It's a hardware two-factor authentication key. Buy them from Amazon. We've got a couple of these in the safe that secure our root accounts, and everyone else then uses Google Authenticator. Quite a cool thing I picked up for any geeks out there. This gives me a replacement for Google Authenticator. So Google Authenticator is tied to your phone. It's only on your one phone and you secret keys. This replaces Google Authenticator, and I can plug this into any machine and it gives you my keys. So that's quite cool. Don't feel on Amazon. If you want to know about that, give me a shout. So I use that for authenticating my keys. There we go. They are quite cool things. Alright, so what is AWS? It is largely an iOS platform, which is infrastructure as a service. So infrastructure as a service is sort of what we get out of Xerox. I'll explain a little bit more about why that's not so, but it's more or less what we get out of Xerox. It is a platform as a service. There is varying degrees of platform as a service. So if you're not sure what, so I'll go back. So infrastructure service basically gives us compute. You want a virtual machine, you want a machine to do something, they give you a machine, and there is Ubuntu, nothing installed on it. There's bare bones Windows. Someone's gone next finish and done the install. That's your machine. You then configure it. Platform as a service it's a configured environment. So I code into that environment, like Heroku for the devs in the room. I don't worry about the infrastructure underneath it. I don't care what it's running. I shouldn't care what it's running. I'm just writing code and committing it to it. Or in some cases, I'm writing databases, database queries, and writing databases and committing to it. Database as a service is sort of a platform as a service. And then SaaS. So SaaS is things like Zendesk, which we just deployed, Salesforce right now. Anything that is you sign up for, it is just software online. You have no configuration of what it is, what it does. You don't care what it is or what it does. You just consume it. Hotmail, Facebook, those things. AWS provides in some form or another all of those different things. Not a great deal of SaaS. There is a couple of them. The other two, very much so, in very different things. It is a platform for scalable web-based apps, or scalable cloud-based apps. Typically cloud-based is web-based, and also efficient apps. I couldn't and I wouldn't take traditional apps and dump them into AWS. So what AWS is not. It's not a traditional hosting service. It isn't Xerox. As much as they share some things, it's not the same thing. It's not effective colo. I've moved a couple of my personal websites across to AWS, and I pay more to do that. For me, it's a learning exercise. I get something out of doing it, moving them across, but actually it's not cost effective for me to do that. It's not high performance. It can be in some circumstances, but it's not. There's nothing in Amazon that gives us the same performance as our Fusion IO cards and the Zego network that powers the majority of the infrastructure in Xerox, including the database stuff. There's nothing in AWS that will touch that. And I've done some comparisons a little bit later on. It's not resilient. So they give you a 3 nines guarantee, which is equivalent of, I think, 8 hours downtime a year. And you can pretty much guarantee you will get downtime. They don't apologise. They don't say, they don't make any excuses for it. Your application is supposed to be designed to fail. Lots of news stories about when different regions in AWS have gone down and people complaining about failures. They didn't design for it. Lots of articles by people like Netflix saying, yeah, Amazon went down, we didn't care, because they designed it to fail. They designed it to fail over. Users might see an impact. You might be looking at a completely different region instead of island, but you'll still get a service. And the last point, they're good at supporting monolithic architecture. Probably get shouted at for my terminology of monolithic architecture, because it's basically, for me, it's anything that's not web scale, to use our fun cliche. So something that's not cloud-based, something that doesn't scale globally and can't individually fail, such as some forms of SQL, things like older versions of Exchange. Your traditional apps. If I turn that server off, I've lost that app. Or if I turn that server off, I need to put something in operation to recover that server or that service. So you can probably think of a few parts of our estate that would be deemed my terminology of monolithic. I won't apologise for that term, that's just my terminology of it. So a quick look at Xerox versus AWS. I've been doing a lot recently around looking at the Xerox contract and various pros and cons of it and so on. Now, what is surprising to me is how much we actually pay for server hosting. So if you break it down into the overall cost of things, this doesn't factor in lots of stuff, so don't take all these figures as gospel, but it boils down to we pay roughly £700 a year to host a server in Xerox. So that's an average cost regardless of size. Now, because it's regardless of size, it's actually quite cheap and quite cost effective for an individual server hosting. Now, if we assume that we've already paid for all of the estate, so our SQL servers here, they're a beast of boxes. They were expensive when we bought them. We bought them 4 years ago. We've depreciated those costs. They don't cost us anything anymore other than the £700 a year. Now, the equivalent of that in AWS actually isn't quite equivalent and is ludicrously expensive. So we're looking at £68,000 a year for a host. So that's infrastructure as a service. You can do that a little bit more cost effectively if you go to RDS. So RDS is Amazon's database as a service. That comes down at £44,000 a year. Each of those, you should note, the 70 grand a year only gives you 4,000 IOPS. The 44 grand a year only gives you 10,000 IOPS. Our Fusion IOs deliver us at least 200,000 IOPS sustainable. They can scale more than that, but sustainable is about 200,000 IOPS. So actually, AWS isn't a replacement for Xerox, and we shouldn't be under the impression that we can just be moving stuff across and making cost savings. There are things that absolutely can be moved across and will show cost savings, but not everything can be. And it's one of the big things I wanted to kind of get across. There's lots of talk about, okay, cool, Xerox is too slow, just bung it into AWS for a little bit, that's fine. Happy to share the calculator. So I actually did these in AWS's calculator. There are lots of things it doesn't factor in for these AWS costs, including bandwidth and I/O, which can add up to 20% of the overall cost to it. We'll share the slides, so that link will go to this calculator and you can have a look with it and play with it. If you go to the calculator, make sure you change to Ireland, because the costs are slightly different for us. So Ireland is our local region that we use. We've now got 2 regions in Europe. We've got Ireland and Frankfurt. We still use Ireland for everything. Geographically, they're actually about the same distance from London. So between Ireland and Frankfurt, there's not much in it. So in terms of latency and stuff, which is great for us, because going forward we can potentially use 2 geos, which are completely isolated from each other, and get resilience of those, but actually potentially not impact our user performance. So what is AWS good for? So if we got any application that can auto-scale, we've had lots of discussions with the teams around things like rate plans, which dev platform for rate plans is going into AWS. We've got a preliminary prod version in there as well, but it is going to have to move. So certain parts of that scale very well. The Node.js front ends, it's great. It's relatively stateless. It's just code. We can chuck it on there. If I lose an instance, fine. The load balancer will deal with that. If I want to add 5 more instances, I can do that. If I want to remove 5 instances, I can do that. Great. Couchbase, not so much actually. So Couchbase scales very well. I can add nodes to Couchbase for however many I want. That's not a problem. Removing nodes actually isn't that easy. Couchbase recommends you remove a node and you wait 48 hours before you remove another node. Now, scaling, you absolutely need to make sure that scaling goes 2 ways. Scaling up isn't the problem. Most applications can scale up. And if you look at the load in Xerox, we're scaled for peak. We can't scale back from peak at all. And that's the problem we have with things like Couchbase, is actually we can't scale back from the peak requirements. So again, make sure you understand the definition of auto-scaling. It needs to go both ways. Now, Amazon absolutely can handle the auto-scaling for you as well. You tell it what metrics to look for, and it will start spinning up new instances for you. So it can be very clever, and also spinning them down again. You build a lot of things within templates, and whether that's an image template or a build template, you build it within AWS, and then AWS will take control of that So it becomes stateless. If you log into that machine and make changes, and then for whatever reason that gets recycled, you will lose those changes. We've had that a couple of times. We've got a scripting box that does a lot of automation for us within AWS, and that's an auto-scaling group of 1, which means that if ever that region fails or that box fails, it will auto get restarted, but it will never be more than 1 instance, which is actually quite useful to have. For that reason, I remember Ollie got one of the teams to rewrite some new scripts, and it put the scripts on it, and then it got recycled, and we lost all those scripts. So we need to make sure that any changes get baked into the image, and then we repurpose that auto-scaling group. Temporary usage. There's loads of use cases from AWS of running batch runs, big analytic queries. So I need 100 servers over a weekend to run a big batch query against a big database. You can do that probably for a couple $100. I can go away and I can provision 100 servers, do a big run, and then deprovision them. It's also its own worst enemy. So there's a couple of great articles about people accidentally putting their AWS security keys in Git. And if you're not aware, there are a bunch of bots that are constantly running, scanning Git public repos for AWS keys. And this one chap, very unfortunate, put his keys in Git, realized it straight away and removed them. It's about a 5-minute window. His keys got grabbed. And that evening, I think 10,000 Bitcoin machines got spun up in his account. And that would have cost him a lot. AWS are actually very good at giving people back the money. They'll give you a slap on the wrist and say, don't do that again. But yeah, he had quite a shock when he had the bill come through. So absolutely, you need to be very careful with AWS. It is only as secure as you make it. Out of the box, they make it quite secure, but it's very easy to make it insecure. So today I've opened up SSH to a couple of my boxes so we can demo things. Normally I don't allow SSH. What I want to do is go on my boxes and do admin, and go into the portal, enable SSH, do my work, and then disable it again. It's stuff like that we not that script on in Xerox. And sometimes it can be a real pain as well. You don't necessarily want to have that level of kind of request mechanism. And then lastly, the one thing that AWS is very, very good at, obviously, is AWS-specific things. Again, I host most of my DNS services, so I get the equivalent of Akamai DNS for about $5 a month. Globally scalable, a guaranteed 100% uptime on my DNS, and anywhere in the world you query one of my domains, and you get I think a sub 5 millisecond response. Pretty awesome for $5 a month. So stuff like that is also quite cool. There's a variety of services. Quick view of high level, some of the different services. Storage, CDN. So storage, I think Amazon have got a great name for things like S3. And there's also Glacier. So everyone in this room, I'd almost guarantee, has touched S3 at some point. The Amazon calculator is actually hosted on S3. So S3 can be used for web hosting. If you've got a static web page, you can actually host it natively on S3. We've been looking into putting things like images and static.lightrooms.com on S3 and hosting them natively on there. Really, really cheap doing that. I was chatting to someone the other day about their partner wanted to host a website. And if it's not a dynamic website, stick on S3, it'll cost you literally a couple of dollars a month. And it's almost unlimited bandwidth and storage. And it's really great for that sort of thing. CDNs, they do have a CDN. Whether it stacks up against fast, easy, Akamai's and so on, I wouldn't make a call. Done an RFP, speak to Chris Woods about it on that comparison. But it's a pretty decent CDN, and again, it's not that expensive. They also do video services. They do some transcoding services and stuff as well. So I'm not sure if What Was Love Film uses that now. I think Netflix uses some elements of it. All their database queries, all their database services. So they have, off the top of my head, MySQL, Postgres, SQL, native SQL. I think Redis, and a couple of other Amazon-specific databases and services as well. DNS we talked about. Analytics, there's various analytics stuff on there. You can read the rest. I'll go through the interface in a second. Let's see that. Interface now. Sorry, wrong button. So this is everything that AWS does. So I'll quickly go through. This is my account, so there's only actually anything visible in EC2 and 3. So I know a couple of you guys are going to be going through the 7 databases in 7 days. I'm going through 7 languages in 7 weeks, whatever it is. So I've actually got a bunch of boxes here, you'll see, which are the languages that I'm going to go through. It's great for it. Spin it up, install the language, power it off. I pay a little bit for the storage of those, but it's absolutely negligible. If I want to power it up, it might, at worst case, if I've got a long evening, it might cost me a couple of dollars to run that for an evening to do some testing and power it off for the end of the evening. It means I can access that lab anywhere in the world without needing my laptop with me all the time. So it's great for that kind of testing. I've got a couple of live machines. There's 2 websites that I've got. The interesting thing, so I've got some scripting stuff in here. So what you can do is also, in terms of security elements, is you've got AWS CLI. AWS is brilliant to consume via API. In fact, that's probably one of its best ways to consume it is via API. There is a CLI which is a very dirty API, but it still works. It does exactly the same thing. It uses the same API calls underneath it. There's lots of language-specific APIs. So our scripting boxes that we use in later rooms are using Node.js. There's a Node API. Just download it. Really, really easy to install. So a couple of scenarios where we're using this API for automation. I'm using this, so I've got a blog that's traditionally has got about 2,000 visitors a day. And lots of those visitors have been US and Indian, which is what I found out. So what I do is you'll see here, I've got a couple of scripts here that start and stop so this is Asia Pac, Southeast Asia Pac, and I've also got US East and US West. Because I don't really want to pay for running these machines all the time, these switch on at specific time zones. So 8 in the morning in Singapore, I fire up an instance in Singapore, which is just a varnish cache, so cheap as houses. And then in the US, I switch one on in US, 8 in the morning, and US East, 8 in the morning, US West, 8 in the morning. It works really well for reducing the bandwidth that has to go across to the UK for the route of that, and increases the response time for those. So New Relic showed a massive drop in response time for those global hits. Again, we've talked about this idea kind of internally briefly about using this for certain things like static content. Not necessarily in this model, but a similar kind of method. What we're using for internally is a couple of policing things. So within our production account, if you don't put a project code when you spin up an instance, there's a script that checks that and automatically powers that instance down. Because we need to make sure that any instances are authorized. If you don't have a project code, you probably haven't asked these guys whether we can spin up and we've got the budget to spin up an instance. And it stops Ollie doing things it shouldn't do.
Well, it doesn't work.
Just puts in rate plans and the project code. We also got one, so a lot of the dev machines don't need to be powered 24/7. So if you power it 8 a.m. till 6 p.m., 5 days a week, it's about a third of the cost of running it 24/7. It's only 50 hours a week. And that turns out at being about $10, $20 a month, which you can't really argue much with. That is really, really cheap for any service. So we've got quite a few different automation tools. There's some admin stuff we do as well. So tagging is really powerful. I actually don't have much tagging in my own account because I don't need to. You need to pay for it. But in the production account, we have tagging in there, so we can actually work out what the different projects are costing us, as well as some of the security groups and so on. So I'll just quickly go through everything that AWS does. Some of them I don't know, so I'll just whiz over them. AppStream is to do with mobile browsing, so there's actually quite a lot of mobile app stuff that it helps with. CloudFormation is actually a fantastic tool, and I'm trying to work with a couple of guys on getting this up and running. So what you do with CloudFormation is you create a template for an entire app. Typically, their examples are 3-tier apps. So yeah, your web front end, your middleware, and your database. What you do is you create a template for that. So I need my database is going to be a MySQL database. My middleware, your front end might be Node.js. You package that up. And what you can do is then create different scaling groups. So actually my Node.js will scale in these building blocks based on these metrics, and you create that as a template. So in theory, what we could do is give you guys a template, give the devs, not more devs in the room, give the dev teams a template, and then you get the choice. So how many front ends do I need or want? How many middleware, how many databases do I need or want? And it will deploy exactly the app you've chosen and exactly the size you need it to be. And then when you finish with that, you click close, and it cleans up everything. If you don't build with things like CloudFormation, it can be actually quite difficult to clean up everything, because there's different things that happen when you deploy an EC2 image. For example, we've got lots of disks lying around in one of our production accounts, which I'm not sure what they're for, because we've created images and then removed them, but the disk gets left. For good reasons, the disk gets left. But for that reason, I'm not sure if they're used anymore. And some things. There's some interesting things with the way that Amazon work their billing. So Elastic IP is free. Elastic IP, so if I spin up a machine, it gets given a dynamic IP. That IP address, I guarantee, will change when you power cycle that machine. And Elastic IP fixes to that. So I've got, as long as I've allocated that Elastic IP, I've guaranteed the same IP regardless of how many times I recycle that. So if you look at my instances, you see these two here. The IP is in blue to link because they're Elastic IPs. In fact, all three of those are. Now you notice that the bottom one here is actually a stocked machine, but it's still an Elastic IP. That bottom Elastic IP is the only one I get charged for, because I've requested an Elastic IP and I'm not consuming it. Amazon say, we're going to penalise you for wasting resources. We're not going to penalise you if you need it. Fair enough. I think Amazon have something like 10 million IP addresses. One of the larger ranges around. An alternative to Elastic IPs is the Elastic Load Balancer. You can put an Elastic Load Balancer in front of one machine. That's fine. Works well. It's actually quite good practice, because then if you decide it's one machine today, and in 6 months' time you think, actually, we kind of need two of them, really easy. You don't have to change anything else other than provision another machine, or clone that one machine. Slight comment on the way Elastic Load Balancers work. You don't have an IP address allocated to Elastic Load Balancer. It gives you an Amazon.com address, and then you use some kind of DNS masking to just mask that through. So we've used that on a couple of occasions. Completely transparent to the user. They don't see the Amazon address, but that's what happens underneath the covers. So moving forward, so CloudFront is the CDN. Cloud Search is their search mechanism. A lot of this is quite obvious what they are. CloudWatch is quite a cool way of monitoring your environment. So you can use, there's a log mechanism, which isn't on the list, but there is a log mechanism which you can use to log to, and you can use CloudWatch to actually generate events from that. Those events could just be an email. Those events could be an automation method. So I've had a failure. Start some kind of activity to recover from that failure, or I've got X number of bookings or whatever. Spin up a new instance. Code deploy is the PaaS side of things. Just don't know what Cognito is. Directory services, we were actually talking about earlier, is an Active Directory service on there. There's lots of discussions at the moment about whether we should have Active Directory against our production services. I'm very much torn against that. Is there a benefit to authenticating, to having machines authenticating when they're in production? Don't know. There's lots of discussion about that. It seems to be causing, infrastructure-wise, a real pain having that there. There's lots of benefits to doing it, but it's also a real pain for management. So DynamoDB is one of the databases. So a couple of the databases are completely in memory. So Redshift is completely in memory and is ridiculously quick, but shouldn't be used for long-term stuff. So we use it. So I'll use Intillery as an example. So Intillery are hosted in our production account. They log a lot of data to MySQL as an RDS instance because it's very robust from that data integrity point of view. They then pipe a lot of that data out into Redshift for the ad hoc analytics, which is just incredibly quick at doing your analytics and getting your results very, very quickly. It's not always up to date because of this pipeline from MySQL into Redshift, but when you need to do analytics, it's lightning. EC2 is Elastic Cloud Compute, so that's your infrastructure as a service. Elastic Cache is like Varnish. So again, you've got something you wouldn't necessarily deploy some varnish instances in here. You could use Elasticache. The big advantage as a replacement to varnish, and potentially I should use this for me instead of having those varnish instances to turn on, is it's global. So actually my Elasticache is then populated globally. So you get to the point of saying, okay, you've got a CDN, but actually do I need a CDN for everything? Or can I use a CDN in conjunction with something like Elasticache, which is that global caching of things? Elastic Beanstalk is if I remember correctly, is kind of dynamic code delivery. So I can pipe Docker config files into Elastic Beanstalk in order to deploy Docker containers. Docker configs. There is a separate thing within EC2 that allows you to deploy Docker containers. It's currently in beta with AWS. But they're quite excited, as everyone seems to be, with Docker, so they're jumping on the bandwagon of that. Transcoder is video stuff. Glacier is just absolutely dirt cheap storage. It's the only time I've seen, I think, 10 nines in availability. And the caveat to that is it's data integrity. So you're pretty much guaranteed that they won't lose your data. You're not guaranteed that you can access your data in any particularly quick time. The rumour is it's cold storage, so it's tape storage. So if you request something from Glacier, it might take a while, minutes, to get it recovered and stored back. So it's not something we would use for active data. We use S3 and then you tier off S3 onto Glacier. Glacier is absolutely it's globally replicated and the rest of it. It's quite a cool thing. IAM is the security mechanisms. I'll come back and talk about security because it's something we're being really, really hot on. We're building. So there's so many stories about people losing their accounts. Again, talking about access keys. An entire company, somehow, someone got their root keys. And it's a really stupid thing to have that available, which is why one of these for our production account is in the safe. And the guys were complaining to me because I basically did a password generator, and that's the username. So it's a cryptographic username, cryptographic password, and then one of these to actually log in. It's stupid. It's a pain in the ass to use. But for that reason, you shouldn't use it. You don't use a root account. You use it to set up all your users, and then you put it away, never touch it again. So I'm bad practice here. For my account, I am using my root account daily. Shouldn't do, but there we go. So IAM is kind of your way of securing everything. I'll go into this quickly because there's some quite cool sides to this. So what I've got, if you look in, I've got a couple of different users in here. Obviously, one is me. And I've got access to this. What you'll notice is I don't have any access keys, but I've got a password set. You'll notice that all the other accounts don't have a password set, but they've got access keys. It's important for how you access the system. So I can log into here using my IAM account, but I can't do anything on the CLI. So the CLI over here, where I'm running things, this is actually running this username called waffle scaling, and it uses the access keys to access this. If someone got that username and password, that username and the access keys, they couldn't actually log in and spin things up. And if I look at the security on this, I've created groups in here which really, really affect how much what people can actually do. So the JSON format, all that account can do is start and stop machines. So if for whatever reason one of you guys got the access keys for that, all you could do is annoy me a bit. You wouldn't necessarily cost me any money, other than starting machines when they ship stuff. So we've painfully got things locked down, which means you can't always do everything in the account, but that's absolutely by design. And sometimes there's going to be some teething issues when you go through it and you think, I can't do what I need to do, and it's just because we lock it down and then we slowly open it up, rather than opening it up and then slowly locking it down, because you're never going to lock it down if you go that way. So IAM is really, really important. It's absolutely fundamental. So I highly recommend everyone to go and play around with AWS. If you sign up for AWS, you get 1 year's free usage. There's a free usage tier, which means you can spin up micro instances and certain other instances for free, and it costs you absolutely nothing. You don't have to. There's not a threshold to say you have to pay. You have to be billing more than $50, and then you get free usage. You get a free usage tier. Everyone does for the first year. So absolutely go and play around with it. But protect your keys, protect your access keys. Learn the security controls. It's really important to learn that. Also, if you learn that, you understand the pain we go through when we set these things up. you can AD link it, as you might have picked up. Given that AD can create problems, we haven't done that. Kinesis is again another kind of in-memory database stuff. It's again really powerful. We're not using it at the moment, but I know I'm speaking to Phil Bates about use cases for both Kinesis and Redshift. There's a couple of new ones in here. OpsWorks is I need to learn more about it because it's around the code side of things, and I think it's around code management and yeah. So it's having the automation elements within it. So if I've got a CloudFormation build of instances, I can plug in OpsWorks into that to say deploy this machine and then deploy that code. So I can start being really dynamic with the way I do that, and actually that's how you can do releases. So within AWS, we get into the concept of doing the ubiquitous immutable service. So actually, once you deploy stuff, because you do things in all these framework type ways, I don't change that instance I spun up. What I would do is I change the building blocks of that instance and I would redeploy it. It's a great way for doing AB, blue, green, whatever you want to call it, type deployment, because I've got some new code, I deploy it, a new instance, or a new group of instances, new application, test that works, switch across production. With Cloud DNS, with elastic load balancers, it's really easy to switch from one code stream to another code stream, prove it, test it, and switch it back. So RDS is traditional databases. They don't do anything clever. You go in there and you choose your cluster size. You can make your cluster scalable across regions or not. Route 53 DNS services, again, awesome. If any of you guys are hosting your own domains and got your own domains, definitely worth looking into. It just gives you a level of global scale. It is very, very cool. As we talked about, says a simple email service, so you can start sending emails out. Don't run your own SMTP service. We shouldn't be running our own SMTP service. We don't run our own SMTP service, not for big mailers. Amazon have their own version. Simple notification services, so mobile notifications, that's what you can use for this, rather than running your own one. SQS is Rabbit, that kind of thing. It's a queue manager. Again, very, very cool and very, very scalable. Storage Gateway is something that's probably relevant to most of you, so apologies for talking too much about it, but it's something that we're quite interested in looking at. So Storage Gateway provides an on-premise cache of your S3 storage. So, for example, here, as you all know, the file shares are always full. If you drop in a Storage Gateway as a virtual machine, we can move the file shares across to that and actually have that backed. So we have an unendless pit of storage, which is S3, and locally we have 5 terabytes, which is probably about as much as we actually use out of the big chunk of storage. So there's some quite cool things in there, in with that. Trusted Advisor is just an analytics, so I can use Trusted Advisor to analyze my account to see whether I'm inefficient or not. VPCs around the networking, that gets really complicated really quickly. So if you want to know about VPCs and stuff, go check to Wally. These two are the enterprise stuff. So on my slide deck on the bottom, there was the enterprise piece. So Workspaces is desktop as a service. So I could go and have a Windows 7 desktop that's hosted in AWS. Kind of cool, kind of expensive if I'm honest. It's something like £100 a month, I think. So if you're a massive organisation, £100 a month isn't that much. For me, it's a lot. I haven't got one. And Zacalo is sort of a Dropbox replacement. It does more than that. It's kind of a somewhere hybrid between Dropbox and SharePoint. The guys at AWS hate when you say it's a Dropbox replacement, but then they talk about it being a content management system, and they always also hate it when you say it's a SharePoint replacement, but it's somewhere between the two. So that was a whistle-stop tour of AWS. Now, one of the things was, so this is the calculator I put together earlier. So one of the things I was keen to again put across to everyone and make sure you understand is that AWS definitely isn't a like-for-like replacement for Xerox. In fact, based on all the different services here, I'm hoping, going through that, apologies that might have been a bit dry going through the list of services there, but actually there's a lot of services there that we can consume directly rather than writing our own versions of. Rather than moving stuff across that we've got today directly into AWS and just running it there, actually, if we rewrite that and move it across, number one, it's going to be cheaper, number two, it'll be easier to manage, number three, it's probably be more performant and more scalable and more resilient. Things that typically are difficult to get all in one. So one of the challenges we've had from the Xerox platform, maybe it's not a challenge, but one of the challenges we've got now with the Xerox platform is the fact that actually it's really, really resilient and rock solid.